Let's try another example of unit conversion. Here's an interesting question. How long does it take for light to travel from the sun to us here on Earth? Do you think it's instantaneously gets here, or does it take some time? Well, it does take some time because there's a speed limit on the speed of light. It's not infinitely large. But how would you solve a problem like this? Well, this is the power of unit conversion. So there's a couple ways to attack a problem like this. One way to do it would be to understand that this is a speed problem. So I could write, let's just try method 1 here. Okay, so method 1 would say the speed of light is equal to the distance over the time it takes. That's just a basic definition of speed. So then this is helpful to come up with a formula, because if you don't know where to start the problem, just start by writing a true statement. You say, okay, how long does it take for light to travel? And then ask yourself, what do you know? Let's say you'd have to figure out, well, you'd have to know the distance between the sun and the earth, and you'd have to know how fast the light travels. So, and then the third thing is the time. So you can see here, this is what you're being asked, how long it takes, and then you'd have to know the speed of light and the distance. So you would be given in a problem like this 2 of the 3 unknowns. You can't do a problem like this where there's 3 possible unknowns and not get an answer without knowing at least 2 of them to get the third. So then you could say, okay, then I'm just going to solve this equation for time. The time it takes is equal to the distance. Now, if I'm solving this equation for time, I can just put the unit of time where speed is on the other side of the equal sign, and put the speed unit where time was. So it's distance over speed. That's just an algebraic shortcut. And now I'd say, okay, now what's the distance between there? Well, you'd be given that the distance between the sun and the earth is known to be about 93 million miles. And the speed of light we know to be 186,000, approximately 186,000 miles per second. So then you could just directly plug them into this equation. So you'd say 93 million miles, and put mi is good enough for miles, and then over speed, which is 186,000 miles per second. Now, how do the units cancel in this case? Well, miles are on top here, they're on the bottom here, but I have the unit seconds in the denominator of a denominator. So technically, the unit of seconds is actually in the numerator. If you don't understand that, you want to review your basic algebraic skills, because we're not going to dwell too much on that in this class. We're just going to assume you have the math skills to understand that this setup is going to give you the unit of seconds. And please bring that up to me during office hours or during class to make sure that you're comfortable with that. So then you'd plug that into your calculator and say 93 million, okay, divided by 186,000 gives me 500. So the time is 500 seconds. And that's the right answer, I believe. If I divide that by 60, yes, that's the right answer. How should I round this answer off? Sig figs again. You have to take sig figs into account in this case, because this is a measurement with some sort of telescope that astronomers use. They have laser techniques as well. And this is an estimate. It's speed of light is actually known with a little more precision, but it's a rounded off number. So if I only know this to 3 sig figs and this to 2, I'd actually technically should, and I want you to practice this, I should round this off to 2 sig figs. Well, written like this, 500 seconds actually only has 1 significant figure. So how do you write the number 500 with 2 sig figs? You have to use scientific notation. So that would be time equals 5.0 times 10 to the second seconds. Now I've written the number 500 like this, has two sig figs, the 5 and the 0, and I'm reflecting that it's 500 seconds and not 50 or 5,000. So that's the right answer. That's one way to do this problem. The other way would be to use the unit conversion technique like I just showed you with the previous problem, calculating how many seconds are in a day. This is a similar type of problem. It's dealing with a rate of something. So go back to the question, how long does it take light to travel from the sun to here on the Earth? So where do you start? Well, you saw the way I did the problem. I had to use the distance and I had to use the speed. The beauty of this unit conversion method is it doesn't matter which one of these I start with. I can start with either one. So I'm just going to start with 93 million miles. I'm going to say, okay, 93 million miles is my beginning point, and I'm going to use the power of unit conversion to come up with the answer. So now my next conversion factor would be have to get rid of the unit of miles. So that the only other thing I know is the speed of light. So I know that in 1 second it travels 186,000 miles. So then I would put the unit of miles on the bottom because it has to cancel. I'm canceling units trying to end up with seconds. And on the top I put the unit of seconds. But now, where does the 186,000 go? Well, it goes with miles because it's written like this. It's considered to be in the numerator, the top of a fraction. So you have to write the number 186,000 like that. And then up on top you put 1 second. So this conversion factor is equivalent to this one. It's just the inverse or the reciprocal. Miles on the top canceled with miles on the bottom. And you can see in one step, I got the answer, 93 million miles. Now I might have said, I didn't specify in this problem what units to give me your answer in. If I said seconds, you'd be done with the problem. You would get 93 million divided by 186,000, and you get 500 seconds, which you should round to 2 sig figs. So I should write that as 5.0 times 10 to the second seconds. And I did the same problem up here using the definition of speed. Notice I solved it for time. I got distance over speed. And here I have distance over speed in this method, in the unit conversion method. Let's say I asked you for the unit or the time it takes light to travel to Earth, but I wanted it in minutes. You could still use either method, but you just have to add on an extra step where you calculate seconds instead of minutes. So you can do it stepwise. Sometimes textbooks do that, where they get an answer here in one unit and then take that answer as the beginning point of the second way. But why don't you just do it in one step? So you can have as many conversion factors as you want in a row. So I'll just write it like this. My new unit's going to go on top. My old unit's going to be on the bottom. So I write 1 second over 186,000 miles. Remember again that this is equal to, that's a true statement. So that's equal to the number 1. I'm not changing, I'm just changing units. So miles on the top cancels with miles on the bottom. And then my last step would be to convert seconds to minutes. So the new unit would go on the top, the old unit would go on the bottom, and write a true statement. And that's also equal to 1. Equal to 1. All right. That pen is a little hard to write with. And then the seconds cancels like that. And you would get, what do you get here? 93 million divided by 186,000 divided by 60. You get 8.333 repeating. So you get 8.3 minutes as the proper way to reflect that answer. And if you really wanted to say to somebody what that means, since it is 8 repeating 8 1/3 exactly, it would be another way to say that would be, it would be 8 minutes 20 seconds exactly. So when you see the sun rise every day, as I mentioned earlier on in the video, when we were talking about time units and the base units, you see the sun about 8 minutes and 20 seconds ago when you first see the sunrise.